Hello, welcome back here, and this is what is the problem related to the block friction. And there are basically four types of friction that we need to study. First one is block friction, wedge friction, ladder friction, and belt friction. To begin with, since we already have the basics of concurrent force system, and the equations of equilibrium for concurrent force system are summation fx is equal to 0 and summation fy is equal to 0. So by making use of these two equations of equilibrium itself, we are going to solve the problems related to the block friction. So this is what is the first statement related to the block friction. Here, the statement goes like this now. The block A, this is block A of weighing 1000 Newton rests over block B of weight 2000 Newton. So this is block B of weight 2000 Newton as shown in figure. So block A is tied to the wall by a string. Block A is tied to the wall by a string, by horizontal string. If the coefficient of friction between A and B, that is the coefficient of friction between these two surfaces, is 1 by 4, and that between B and the floor, that is B and the floor, coefficient of friction is 1 by 3. And what value of the force P is required to create impending motion when P is horizontal? So when P is horizontal here and when P makes an inclination of 30 degrees. So there are two conditions that we need to solve here. So to start for the first condition, for first case here we need to first draw free body diagram. Okay. Then we need to apply three protocol. Three protocol is self weight will always be vertically downward. Reaction will be always, or N will always make an inclination of 90 degrees. Then frictional force will be always opposite to the movement of the body. If we take care of all this particular condition, then the solution will be very much easy. So first, to draw the free body diagram, we need to separate these particular two bodies now. So the first body is block A. This is block A. And the second body is block B, which has been placed below here. So block A weight is 1000 Newton, which has been mentioned in the statement of the problem. So if it is 1000 Newton, which indicates weight will be downward, so 1000 Newton will be downward. Similarly, block B is of weight 2000 Newton. So again this will be in the downward direction, 2000 Newton. So these will be the two weights now here. Now block A has a force which has been connected to the left hand side. Now what will happen to this particular force or the string force here? Now if this particular block B has a force been applied P towards the right hand side, if has this particular force P is towards the right hand side, what it indicates? Block B will move towards the right hand side because P is applied towards the right hand side. So what should be the direction of the frictional force? Frictional force direction will be opposite to the movement of the body. As force P is applied towards the right hand side, frictional force will be towards the left hand side here. So this I shall call it as F of F1. So similarly, here also we will be having a frictional force here, which will be called as F of F2. Both will be different. Reason behind that is, here coefficient of friction between block A and B is 1 by 4 and between B and floor is 1 by 3. So coefficient of friction is different. So it will be called as F of F2 and F of F1. So both these surfaces are in contact now. As this force is towards the left hand side, to maintain equilibrium, so frictional force here on this particular surface will be towards the right hand side. So both the forces will be equal in magnitude and opposite in direction. Now as 1000 Newton is downward, B will offer a force such a way that 1000 Newton does not move in the downward direction. So frictional force or the normal reaction will be in the upward direction. So this normal reaction, what I call it as N2. Same N2 will be transferred here also, because these are the two blocks placed one over each other. So first weight is 2000 Newton, which is self weight 2000 Newton downward. Second is the weight that has been transferred by block A. That means if I place one over each other, now I am placing calculator over the paper. What indicates? Calculator will transfer its own weight to the paper and paper will either further transfer to the bottom object. So whenever you have one object been placed one over each other, the object will be transferred to block A the weight will be transferred to block B, and B will be transferring the force to the ground. So this will be the force here, and that force will be called as N1. Now if this force is towards the right hand side, so T will be towards the left hand side. So this will be the reaction force system. So these particular conditions we need to solve here now. To solve here, I need to use equations of equilibrium. Summation Fx is equal to 0, summation Fy is equal to 0. So block A, when I make use here, so block A is been placed here. I shall make use summation Fy is equal to 0. If I make use summation Fy is equal to 0, so if I make use of summation Fy is equal to 0, so here 1000 is downward. I shall draw this particular block here separately. 1000 is downward. T is towards the left hand side. Frictional force F of F2 is towards right hand side. N2 is applied upward. So if I apply the equations of equilibrium here, minus 1000 because it is downward, plus N2, that is equal to 0. So N2 will come out to 1000 Newton. So same condition, there is a relationship between F of F2 and N2. What is the relationship? F of F2 is equal to mu times of N2. So F of F2 will be equals to mu times of N2. Now mu here is coefficient of friction between block A and B is 1 by 4. So mu is 1 by 4 times of N2 value is 1000. So into 1000, which will come out to 250. 1000 divided by 4, which will come out to 250 Newton. So F of F2 will be equals to 250 Newton. So similarly, take summation Fx is equal to 0. If you take summation Fx is equal to 0, minus of T, because it is left hand side, plus of F of F2 is equal to 0. So T is equal to F of F2, which is T will be equals to 250 Newton, because F of F2 is 250, so T is equal to F of F2, where is 250 Newton. So T will be equals to 250 Newton. So what you have calculated here, this to be 250, N2 to be 1000, and T to be 250. So whatever the parameter, unknown parameter were existing for block A, all have been calculated now. Now we should show to block B now. To calculate all the unknown parameter pertaining to block B, I shall draw again the free body diagram for block B now. So free body diagram is, one force is N2, which is downward, then self weight, which is 2000 Newton downward, P towards right hand side. Then as it is right hand side, frictional force will be towards the left hand side, F of F1, and frictional force here is called as F of F2 here. Frictional force here is F of F2. Now what is the value of F of F2 here? F of F2 value was 250 Newton. F of F2 value was 250 Newton. So you simply need to substitute here F of F2 to be 250 Newton. And to resist all this vertical force, there will be force called as N1. So if you take summation Fy is equal to 0 here, what will happen now? Here minus of N2 downward, minus of 2000 downward, plus of N1, that is equal to 0. So N1 will be equals to N2 plus of 2000. So what was the value of N2 now? N2 value was 1000 here. So substitute the value of N2 as 1000 plus of 2000. So N1 will be equals to 3000 Newton. If N1 is 3000 Newton, so what is the equation for F of F1? Equation for F of F1 is mu times of N here. So F of F1 will be equals to mu times of N1. So which will be mu value. Mu value is coefficient of friction between B and the floor is 1 by 3. So coefficient of friction between B and the floor is 1 by 3 times of 3000. So which is frictional force of this one. So frictional force will be here will be 1000 Newton. So if frictional force is 1000 Newton, now that is F of F1. Now look back here this particular diagram. If I need to find out the value of force P, then I need to consider summation Fx is equal to 0. If I consider summation Fx is equal to 0, here f of F2 is towards the left hand side, minus of f of F2, minus of f of F1, plus of P, that is equal to 0. So P will be equals to f of F2 plus f of F1. So P will be equals to f of F2 value is 250 plus of f of F1 value is 1000. F of F1 value is 1000 here. This value is 1000 Newton. So plus of 1000 Newton. So P value will come out to 1250 Newton. So this is how we are supposed to solve problem related to block friction. That is, you calculate the value of P when the string has been connected in the horizontal direction. So this is what is the solution when P is connected along the horizontal direction. The second condition is when the P is connected along the inclined direction. So remaining all condition will remain same. Here it is 1000 Newton. Here this will also be 1000 Newton. And here this will be 250 Newton. There won't be any change here. This will also be 250 Newton. And this will be again 1000 because N2 value is considered as 1000. N2 value is considered as 1000. Self weight is 2000 Newton. P here now instead of horizontal, it will be taken upward, making an inclination of 30 degrees upward. So this will make an inclination of 30 degrees upward. And this reaction will be called as N1. Frictional force will be F of F1. So if we solve for here, there won't be any change for the solution of block A. Block A will remain as it is because P is no way connected to block A. P is connected only to block B. So whatever the solution that will vary is only pertaining to block B because P is connected to block B. Now if I want to find out the solution for this, so P has to be resolved along the horizontal direction. If you resolve P along horizontal direction, P along horizontal direction will be P cos of 30 degrees and along vertical direction it will be P sin of 30 degrees. Now I will be applying summation Fy is equal to 0. If I apply summation Fy is equal to 0, minus of N2 minus of 2000 plus of N1 plus of P sin of 30, that is equal to 0. So here N2 value is already been given, which is nothing but 1000. So N1 plus P sin of 30, P sin of 30 will be equals to 1000 because N2 value is 1000 here. N2 value is 1000 plus of 2000. So N1 plus P sin of 30, which will come out to 3000. So make this particular equation as equation number 1. So both are unknown, keep it as it is. Next you consider summation Fx is equal to 0. If we consider summation Fx is equal to 0, look at this diagram. Minus f of F1 minus of 250 because it is left hand side plus of P cos of 30 is equal to 0. So f of F1 is what? Which is nothing but mu times of N1, which is 1 by 3 times of N1. So this will be minus 1 by 3 times of N1 plus P cos of 30 degrees is equal to 250, which is equation number 2. So if you substitute this in the calculator and check out, the equation will be, go to mode, equation 5, two unknowns. First coefficient is 1. Then next one is sin of 30. Next one is 3000. Next it is minus 1 divided by 3. Minus 1 divided by 3. Next is cos of 30. Then 250. If you solve this, the value of P shall come out to, if you solve this and check out, the value of N1 will come out to, 2394.79 and the value of P, which is the second term, which will come out to 1210.43. 1210.43. If you check out here, so first coefficient of N1 is 1. Second coefficient of P is sine of 30. Sine of 30 will be 0.5. Third coefficient is 3000. Here it is 3000. Next one, here it is 1 by 3. 1 by 3 means 0.33. Next coefficient is cos of 30. Cos of 30 will be 0.866. Next one will be 250 towards right hand side. So 250 towards right hand. If you substitute here, N1 will come out to 2394 and P will come out to 1210.42 or 43. So this is how we are supposed to solve when P is placed horizontal, when P is placed as inclined. So basic here is, first we need to draw the free body diagram. Self weight is downward, reaction is perpendicular, and frictional force will be opposite. So thank you. Have a nice day.